Now, Asher talks about various outlet configuration of centrifugal fan and their rumble condition. As we see in this picture, we have one, two, three, four, five, six different arrangement. Now, the very first one we have mm, the fan, which is throwing duct in horizontal motion, and you see the very normal, as usual, duct arrangement here. And then the second picture we have the fan is throwing air at a angular direction, and then we got another duct arrangement here. Rest of the picture where mm, the centrifugal fan is throwing air at upward motion, and we see different duct design or different duct configuration or system configuration of duct. Well, the system or the ducting system that affects the performance of the fan. So both of them has to be synchronized, fan as well as the duct system. Now, starting with the very optimum scenario, this is the very optimum scenario. Let's focus on this. So this is the centrifugal fan we have now. This centrifugal fan can be at a fan coil unit or at an air handling unit or maybe in exhaust system. Doesn't matter as long as it is a centrifugal fan. This applies. Now we see at any centrifugal fan there is an opening. So let's say this is the opening of the fan. And we see this is the height. So let's say the height of this opening is B. Now what Ashley says us, after the centrifugal fan, you must have a flexible joint. It may be cloth or it may be fiber, doesn't matter, whatever comforts you. And after that, we must carry on duct similar to the size of the opening of the centrifugal fan. Let's say the centrifugal fan opening here at this point is A by B. Or let's take a numerical value will be, more touching. So let's say this is 48 inch. And this one is like, let's say 12 inch. Okay, so if the opening is 48 inch by 12 inch, we have to carry on the opening, the duct, similar to the size of the opening, for a length at least 1.5 times of B. So if here we see the B is 12 inch height, don't get confused with this B. So yeah, let me rewrite here, B. So if the B is 12 inch, in that scenario, 1.5 times of B, that means 12 multiplied with 1.5. What we have is 18 inch. This is the minimum length we should carry on a straight duct similar to the size of the centrifugal fan opening. After that, we are going to meet the regular duct design or duct design parameter. Let's say here we have the duct that we do calculation as per our requirement. Now we have to connect this duct with this fan system. In this case, we are going to need a slop or neck in here. In this connection, Ashley recommends a slop of 1/4 if the velocity is below 2000 feet per minute. So the slop here we have 1/4 if the velocity is below 2000 feet per minute. However, it is always preferred slop 1/7. That is actually preferred one. Now there is another one. This is as per Asher is very good. So similar arrangement. We have the flexible connector here, and also A. We have already discussed this. So this is this is similar. No, nothing new here. Similar to this scenario. Always we have to carry on the straight duct after the centrifugal fan for a length of 1.5 times of the centrifugal fan opening, as we have discussed earlier. Now, in this particular scenario, dimension A should be 1.2. Yes, everything is similar. Yeah. Right. So let's talk about this one, the good scenario, as we are throwing as vertically upward motion. Looking at this four picture, it is very easy to understand. This is the optimum scenario of vertical, no, if you want to throw air, vertical motion. And if you see the second picture here, a particle is throwing the air, the duct is, very sharp end, so you're not going to get a good performance here, and a high amount of loss will be here, similar to this and this. So these are not acceptably good performing condition for centrifugal fan, but if you are throwing the air at the vertical upward motion, this one is the ideal implementation to follow. Now, everything is same, only different is the right turning vane. You need to provide vane here in case you are throwing at upward motion just to get the lamina faster. Now, in practically, yeah, we must follow this. Other than this, it will be very difficult for us to make a system which is vibration and noise free. And from the real exam, you might get some question from here, so be well prepared.